So we already know derivative of natural log is just 1 over x if we're doing natural log of x. If we are doing the derivative of natural log of, I have used a different letter here. I have used u. That u is to represent anything. It might just be an x, but it could also be 2x minus 7. It could be x squared. It could be the square root of x to the third. It could be whatever, right? So if you have the derivative of natural log of u being something other than just x here, your derivative is still 1 over whatever the u was, and then you will multiply it by the derivative of whatever the u is. So the u is your like inside part here. So it's chain rule for this. So that can either be written this way, du over dx, that is the derivative of u, or I prefer this notation right here, the u prime. That also just means the derivative of u. So it's written twice there just because it's different notation that you might see. Okay, so if we have a problem like example 9, give you a second to write it down. We got the derivative of natural log of 3x plus 2. Oh, sorry. There we go. So, natural log of 3x plus 2. Our outside function is the natural log of x, and the inside part is the 3x plus 2. So when we take the derivative of the outside part, we are going to get 1 over 3x plus 2. But then we must multiply by the derivative of the inside, which is just 3 here, and that's like 3 over 1. So that's going to be 3 over 3x plus 2. So that would be our answer for that problem. Okay. So, left too much space there. The next question is f of x equals natural log of x to the 4th. So this one's a little bit different. All right, so this time, what's our outside function? To the 4th power, right? So our outside function is that stuff to the 4th power. The inside function is our natural log of x. So when we take the derivative of this, we just use the power rule for the outside function. So that's going to give us 4 natural log of x cubed. And then we are going to multiply by the derivative of the inside. The derivative of the inside is natural log of x. What is the derivative of natural log of x? 1 over x. So our answer for this one will be 4 natural log of x cubed over x. So if you have a function like number 9 where the natural log is your outside function, you end up with an answer that does not have a natural log in it anywhere. But if it's part of your inside function, you'll still have natural log in your answer. There. Okay, questions? All right, the other ones we have to do are e's. And e's are pretty easy because the derivative of an exponential function is itself, right? So derivative of e to the x is e to the x. Well, if we update that, where instead of e to the x we have a u right here, then we would have the derivative is still just itself, e to the u, but you must multiply by this u prime right here, which is the derivative of u. Okay. So for example 11, we've got the derivative of e to the negative 3x. So the derivative of an exponential is just itself, right? So we just have e to the negative 3x. But we must multiply by the derivative of the u, which is our exponent, right? That exponent is like our inside function. So the derivative of the negative 3x is negative 3. And so there's a couple ways they might leave this answer. You might just see it written negative 3e to the negative 3x. Also, since that has a negative exponent, there's a decent chance that they will write it this way, negative 3 over e to the positive 3x. E's should be very simple for us to deal with. The problem with e's is that it's so subtle sometimes that we forget to do chain rule with it. For example, like if we have e to the negative x, right? What is the derivative of e to the negative x? It's negative e to the negative x. But it's so subtle sometimes because the only thing that makes this not just a straight derivative is that negative right there. So you got to do e to the negative x, and then you got to multiply by the derivative of the negative x, which is where that negative out front comes from. So, so it's really, pretty straightforward. It's just making sure that we do every piece of this. Because what we'll see, and you're going to see on the assignment I'm going to give you today, we're mostly just going to work on the assignment today, is that these are usually found within like a larger problem where you might have to do a product rule or a quotient rule or something like that within the problem. So, your assignment that you're going to do for me is not this, because that was the other night's assignment. You guys today are going to do 168, and what did I put on Canvas? Let's see. Um, 47 through 85 odd. It's a lot of problems. Some of them will be really quick. Some of them, when you get towards the end, are going to be a little bit more extensive. Please make sure you're checking the back of the book to make sure you can get your answer to match what's in the back of the book. You got quite a bit of time, so hopefully you can get most of this, if not all of it, done before you go. Okay.